right, so we are going to be solving absolute value equations, and if you preview the back inequalities here, the thing about absolute value equations that's interesting is that they end up with multiple answers. So let's think about that for a moment. I'm just going to add like an extra little example up here. If I told you that the absolute value of x is 5, what number might x be?
5.
X might be 5, or x might be what? Negative 5, right? So there's more than one thing it could be.
Wait, why can it be negative 5?
Excellent question. Who wants to explain that one? Why could x be negative 5? Isan. So when I put negative 5 in that absolute value function, it does turn positive, okay? So absolute value is the distance a number is from 0, and negative 5 is 5 away from 0, and positive 5 is 5 away from 0. Okay. If you need a copy of the notes, come grab one. Here we go. So we have to isolate the absolute value, and what that means is this absolute value with the bars on it, it has to be there by itself. Which problem does not have the absolute value isolated? Number 4. See, number 4, I've got a 6 and I've got a negative 7, so that one is not isolated yet, so that would have that extra step. Then it says to write 2 separate equations, because remember, what's inside the absolute value could be the positive number or it could be the negative number. Then you are going to graph your answers on a number line. That might seem a little bit silly for equations, but when we get to inequalities, you'll understand more why. And then check for extraneous solutions. An extraneous solution is when you do all the steps right and you still get a wrong answer. And I'll show you how that might look, okay? All right, let's zoom in a little bit so we can see the problems that we're gonna work on. So if I know the absolute value of 2x minus 5 equals 9, then what's inside the absolute value might equal 9. Or what's inside the absolute value might equal what number? It might equal negative 9. Because if it equaled negative 9 and I took its absolute value, I would then get positive 9. So there are 2 equations. All right, some of you probably got some practice last year in geometry class solving linear equations, and some of you probably did not have so much practice with that. So we're in different places with that, but let's just try solving these. I'm gonna get the x by itself by adding 5 to both sides. And then if it's 2 times x, I can undo that multiplication by dividing by 2. Okay, so I found one of the answers. Go ahead and find the other answer. Okay, so the same steps, just different answers. When I add 5, I get negative 4. And then when I divide by 2, I get negative 2. Now, it's early. It's very possible I can make mistakes with adding, subtracting, multiplying, dividing. So let me know if you catch a mistake, okay? So 2 answers. Now we can check them to make sure they're right, okay? Here's how we check for extraneous solutions, and it's going away. Give me a sec. Okay, so I can check and see if 7 is a solution. Notice I boxed it so I can separate the check from the answer. This is the answer, this is the check. Absolute value of 2 times 7 minus 5, does that equal 9? Absolute value of 14 minus 5, and then absolute value of 9 equals 9. Is that true? Yeah, it worked. And then we'll check negative 2. 2 times negative 2 minus 5 equals, oh, sorry, I didn't go back to the original, sorry. Absolute value, and then positive 9. So I got rid of that negative because I'm doing absolute value, I'm doing the original equation. I got absolute value of negative 4 minus 5 equals 9, and absolute value of negative 9 equals 9. Is that true? Absolute value of negative 9 equals 9? Yes. So they both work. They're both good answers. Okay, so now I want you to try number 2. And while you do that, I will update the attendance. So here we are. I subtracted 5 from both sides. I got to 1/2 x, and most of you guys told me you divided by 1/2. We did say we could multiply both sides by 2. That would work too, but I'm going to do what you guys did. I'm going to divide by 1/2. Okay, and we said that if we want to divide 2 into halves, that there are 1, 2, 3, 4 halves in the number 2. That gives us x equals 4. You can use a calculator if you want to verify that. Same thing here. Dividing by 1/2 actually doubles it. And I get x equals negative 24. Did anybody check these yet? See if they work? All right, so we check them just by putting them back in. Check. Absolute value of 1/2 of 4 plus 5 equals 7. What's 1/2 of 4? You guys know what 1/2 of 4 is? 2. Okay. So absolute value of 2 plus 5 equals 7. Is that going to work out for us? That one checks out, right? And then the other one was absolute value of 1/2 of negative 24 plus 5 equals 7. Absolute value of negative 12 plus 5 equals 7. Absolute value of negative 7 equals 7. Is that true? Yep, because absolute value of a negative will give you that positive answer, so that's also right. So you might be thinking now, why would I bother checking, right? I promise it's coming. Let's try the next one, number 3. All right, so I just did a little bit of solving of linear equations here and probably ended up in the same place you guys did. Did anybody check these yet? Let's check them. All right. Absolute value of negative 7 equals negative 7. True or false? It's false, right? That's not true. So we got an answer here, but it's not working. Let's try the other one. Absolute value of 3 times 5/3 plus 2 equals negative 7. 3 and divided by 3 cancels, so I get absolute value of 5 plus 2 equals negative 7. Absolute value of 7 equals negative 7. True or false? Also false. It doesn't work. All right. So I want you to take a minute and talk to people around you. If there's nobody near you, talk to somebody on the other side of the room about what happened there. Was there any clue from the start that this wasn't going to work out? All right. All right, so just to review what we just did, we found that these solutions didn't work, and so we're going to write no solution for this problem. And then Dion let us know that anytime the absolute value is isolated and it equals a negative number, that will be no solutions, because you can't have an absolute value equaling a negative number. All right, the next one, we do have to isolate the absolute value before we can write 2 equations. I'm not going to write 5 and negative 5. That's not going to work. You have to isolate the absolute value, and then you can write the 2 values. So what do I have to get rid of first? So I want to get rid of the stuff outside of the absolute value. So here's 6 and 7. Now, literally, you could do either one, but let me make this point to you. If I get rid of the 6 first, I would have to divide this by 6, this, and I would end up with 7, 6, and 5, 6. So I'm going to try to avoid that, okay? It's possible to do it that way, but I think it might be easier to get rid of the -7 first, with what on both sides? Yep. So I'm going to add 7 first. Notice I have not written two equations yet. Is my absolute value isolated yet? No. So now I have to get rid of what? The 6. When I divide both sides by 6, this left side is all together. So when I divide it by 6, that cancels out. And then I divide this by 6. And now I have absolute value of 2x plus 3 equals 2. So now you can go ahead and solve that with two equations. All right, did you guys get the same answers as me? Let me know if I made any errors. All right, so it did say to graph these on a number line, and they're just going to be points on a number line. I thought of it because this last one's a little bit harder than the other ones to graph on a number line. When you make a number line, try to space your numbers as evenly as possible. Okay? Now, -1/2's not too bad. I remember that one's going to go between 0 and -1. But how about -5/2? What would that be as a decimal? -2.5, good. So you have to kind of think about what would that be as a decimal in order to graph it, and -2.5 would be between -2 and -3. So that's what they're saying to do when they say to graph your solutions. We can't graph no solutions, but we can go up and graph the other ones up here. Something like -24, I'm definitely not going to want to make 24 marks on a number line, so maybe we can count by something, like count by 4s or something, okay? So for this one, I'm going to go down here. So I'm going to have this number line, do my very best. So here's where +4 is, and then I'm going to count by 4s. So going back, I've got 0, -4, -8. Notice that you do have to go by the same amount each time. You can't just jump all the way to the number you want. All right, so there's finally -24. So I've got 4 and -24. And then we're going to graph number 1 as well. I think I might do that above it because I'm running out of space. I'm going to give you a minute because I know some people are writing that, and then we'll go back and graph number 1. All right, so going to the first one, I'm just going to graph that one, I think above it. All right, so I need -2. So here's my 0. There's -2. 1, 2, 3, 4, 5, 6, 7. There's 7. Okay, so I got -2 and I've got 7, and I graphed it. If I tell you that the absolute value of x is greater than 5, would you agree that it's possible that x was greater than 5? X could be 6, 7, 8, 9, 10. That would make sense? Okay. So x might be greater than 5. Okay. But what about the negatives? What negative values would make that true? Give me a number that's negative that would make this a true statement. -6, -10? Yeah, those are both good. So -6, if I take the absolute value, it's 6 and it's greater than 5. -10, if I take the absolute value of -10, that's greater than 5. So these numbers are what relationship to -5? Good morning. Are they greater than -5 or less than -5? What are they? So greater than -5 would be like -4, -3, -2, right? So they're not greater than -5, they're what? They're less than. So do you see how that's interesting? The numbers that make this true are either what you would expect, x is greater than 5, or when you go to the negative, this becomes a less than. This flips, okay? Says write two separate equations. We're writing two separate inequalities. Okay? All right. So I want you to try it. I feel like that was the only thing that changed for number 5. So let's try number 5 on your own or with people around you. What do you guys think of the first part? Did I make any errors in the first part? Okay. Second part, 2x minus 3, but instead of less than, what symbol should I put? Greater. Good. Does anybody get these confused? The less and the greater? I get them confused all the time until I realize that the less than looks like an L. See? Less. The less than looks like an L for less. That helps me. Okay, so that's the greater. So if I add the 3, I get 2x is greater than 8. And then I get x is greater than 4. Did you guys get that? I don't know. Oh, yeah, because I put the wrong number. So I did all the right steps. I just put the wrong number, right? So this is 10. And then this is 5. Is that right? I feel like something's wrong there. Oh, it's supposed to be negative, right? All right, guys. All right. This is why I pay you so much. 2x minus 3 is greater than negative 7. We got it now, right? I don't even know where I pulled that positive 5 out of. And now I'm going to add the 3. And I get 2x is greater than negative 4. And some of you guys are just going to let me make up these numbers like that. X is greater than negative 2. All right. Is that okay? Yeah. You sure? Okay. So this is why the number lines are helpful. Because now I need the numbers that are less than 5 and greater than negative 2. So let me get a 0 here. There's my negative 2. And there's my 5. First thing is, if it's less than, but not less than or equal to, should I be using the solid dot or the open dot? So open dot, good. So I'm going to use an open dot. That means not including this number. You can do it right on the number line if you want. I always do it a little bit above just because I have trouble reading it when it's on the number line. And then also here. Is it possible for a number to be both less than 5 and greater than negative 2? Yeah, it's the numbers in between. So in this case, it has to be both less than 5 and greater than negative 2. So putting those answers together, I would say x is between negative 2 and 5. Puts my two answers together. Can't always do that. Sometimes they won't go together like that. We'll see an example soon. All right, let's try number 6 and we'll see if we can do it without any typos. Some of you are done. If you're done, you can compare with somebody. All right, I've got x is greater than or equal to 10/3 and x is less than or equal to negative 2. If you have those, raise your hand. Only one person. Okay, if you have something different, raise your hand. Solid dots because it could equal those numbers. And Morgan told me that 10/3 is 3.3 repeating, which I cannot put precisely, but I'm going to do my very best. I don't want it to be at 3.5. It's going to have to be before 3.5. All right, so this time I have less than -2 and I have greater than 10/3. Can I be both of those things at the same time? What number would be both less than -2 and greater than 10/3? There's none, right? So this time it's an or. I could be less than 10/3 or, I'm sorry, I could be less than -2 or greater than 10/3, but not both. So this time when you put them together, you can't put them into a single statement. You've got one or the other. All right, and then this up here is telling you that if you have a less than symbol to start with, here we had a less than symbol to start with, you're going to end up with one of these like barbell looking ones. It's between two numbers. If you have a greater than to start with, you're going to end up with the arrows going opposite directions like this one. All right, try number 7. When you try number 7, remember you have to isolate your absolute value first. Okay, so the first thing I had to do is get rid of that 2, and I saw some of you get rid of that by dividing, right? So it's 2 times the absolute value, so I get rid of it by dividing on both sides. And then I have absolute value of x minus 4 is less than or equal to 5. Once you have it isolated, that's when you can write your 2 different inequalities. First one, and then the second one. All right, can a number be both greater than -1 and less than 9? Yeah, like 0, for example, right? So we were going to say that x is between -1 and 9, and we can write it this way. Here's the x. X is bigger than the -1, but less than the 9, of course, or equal. And then when x is between the two numbers, we're going to write it in this style where x is between those two numbers. All right, so I started number 8, and I get to -1/2 x is greater than 3. How many halves are in the number 3? 6 halves in the number 3. Good. So I know that 3 divided by 1/2 would be 6, but I have to divide 3 by -1/2. So that would give me what number? -6. And then there's one more tricky thing about dividing by a negative. Here's my x. There's my -6. Does anybody remember when you have an inequality and you divide both sides by a negative number, what happens? It flips. Good. Okay. So this greater than becomes a less than. And that's tricky because look, I flipped it over here, and now I'm flipping it again over here. There are a lot of things that flip your inequality, and you just have to make sure that you don't miss any of them. So this, now I have x is less than -6. And that's because of that negative that was in front of the 1/2 x. It's going to happen on the other side too. And because of those flips, it might flip what we expected to get out of our graph. Okay, how many halves are in the number 7? 14 halves are in the number 7, and when I do a negative divided by negative, I will get a positive, right? All right, but instead of a less than, I'm gonna put what symbol? Greater, good. All right. Yes. Okay, so we had less than -6 and greater than 14. So let me make that -6 and 14. I think I'll just count by twos this time. So here's 0, 2, 4, 6, -2, -4, -6, 2, 4, 6, 8, 10, 12, 14. Okay. So I've got open dots at 14 and -6. Is it possible to be both less than -6 and greater than 14?
Yeah.
What number would that be? Yeah, it does have to be or, because you can't be both. So you could be less than 6, -6, or you could be greater than 14, but you cannot be both. Okay?